Hello everyone, welcome back to my channel CodeVish. In this video, we are going to discuss about Kubernetes Overview. So let's begin. Kubernetes was built by Google based on their experience of running containers in production. It is an open source project and one of the popular container orchestration technology available in the market. We have a lot of different container orchestration technology available in the market such as Docker Swarm, Ansible, Apache Mesos, and a lot more. So now first let's understand what Kubernetes is. To understand Kubernetes, we must first understand two things: container and orchestration. Let's move to container. In this container overview section, we will discuss about two things: why we need containers and what it can do for us. So suppose we have a requirement to set up an end-to-end stack including various different technologies like a web server, Node.js, a database, MongoDB, a messaging system, Redis, and orchestration technology, that is Ansible. Now there are multiple issues developing this application. So first one is compatibility. So compatibility with underlying OS. We have to ensure that all of these services should compatible with OS version we are trying to use. Second, the competencies between the services, libraries, and the dependencies on the OS. So as in this diagram, we can see how different components and services are dependent on each and every layer of the infrastructure. So this matrix is referred to as the matrix from hell. Now suppose a new developer is onboarded. So they may face issues while setting up the application as they have to use the exact library versions and services version. It may happen that one of the developer is interested in one OS and other developer is interested in other. Hence there is no guarantee that application will behave same way on different OS. So we needed something that could help us to resolve these compatibility issues and also to modify the components without affecting underlying architecture. So here Docker is one solution which comes in the picture. With Docker we can run each component in separate containers with its own set of libraries and dependencies. But one thing to note here, they share same OS and kernel but within separate containers. So now let's move to understand what is containers. So in our general life, containers is something like where we can place our things in. So for example, we can have a spice box where we are keeping our spice. So that is also one example of container in real life. But when it comes to application, so we can think it is a box where we can keep all our application libraries, configuration in one place, so that if some other person is trying to run this application, no extra configuration is needed. So containers are completely isolated environment. They have their own process, networking interfaces, just like VMs. They all share same OS kernel. So now we got one more term that is called VM. So we should know what is the difference between VMs and containers. So let's move. So now in this picture, on the left hand side we can see the VM architecture and on the right hand side we can see the Docker architecture. So in this diagram you can see that on top of infrastructure OS is lying, and on top of OS there is a container runtime, we can say, that is Docker. Now on top of Docker, our application, or we can say the components, are running in the form of containers. So as we can see, they have their own set of libraries, dependencies for each and every component, but they share the same OS. Whereas on the other hand, we can see in case of virtual machines, we can see that on top of hardware infrastructure, there is one OS lying, and on top of OS, they are keeping hypervisor. So hypervisor, for example, if you heard of VirtualBox, so this is one example of hypervisor out there. So on top of hypervisor, we can see multiple virtual machines are there. So inside virtual machine, we can see they have their own OS, their own set of libraries and dependencies, and on top of that, application is running. Same way on another virtual machine, they have their own OS, their own libraries and dependencies, and the application is running. So this is one of the difference we can see as per the diagram. Now we can see that in case of virtual machines, there is a higher utilization of underlying resources, because we can see there are multiple virtual machines running and kernels. In case of Docker, they are running in the form of containers. So Docker are very lightweight. They comes usually in megabytes, and they boots up in a fraction of seconds. On the other hand, VMs are very heavy. Usually they come up in GB, and they boot up in minutes. Now in case of containers, we can see that containers are lessly isolated because they are sharing the same OS, and multiple containers can share the same resources. So for example, it may happen there are two applications running in different containers and they are sharing the database. So that is one of the example. And in case of virtual machines, so they are completely isolated from each other because they have their own set of application, OS and everything, and they don't rely on underlying OS. So now we should know how we can utilize this container technology. So here Docker Hub comes in picture. So Docker Hub, you can think it as a public or private repository where you can pull the images from various applications. So for example, for Node.js, there is already official images there. Same way we have Redis and a lot of things. Even you can create your own application image and you can push them to your Docker Hub public and private repositories. So for example, now you want to run the application, any application or any image in your local system. So this is very easy. You just need to run only one command, that is docker run application name. So in case of Nginx, if we are running docker run Nginx command, so it will pull the image from the Nginx and it will start running that image in the form of containers on our Docker host. Same way, you can, if you want to run Redis image on your system, you can directly run docker run command. Then suppose you want to run Node.js on your system without doing anything, you just need only one simple docker run command and it will do everything for you. Now for example, I got one Node.js instance running on my system. I can run multiple instances as much as I want. So for example, I'm running now second instance, so it also come up. Then we can also run multiple instances. So in my case, I run only 3 Node.js instances on my application. So here we got a new term, as I discussed earlier, image. So now we should know what image means. So image is simply, you can think it as a template from where containers are built. So you may write your own set of Docker file and Whenever someone wants to run your application or your application as a container, they just need to run only docker run command. So we can see here we have docker container 1, docker container 2, docker container 3. Now we should know the advantages of container. So traditionally what developer does, so they develop an application and they hands this application over to operation team to deploy and manage it in production environment. They do it by providing a set of instruction such as how the host must be set, prerequisites and new dependencies, how dependencies are configured, and all of this. They record all these information in a guide. So what operation team does, they use this guide to set up the application, since operation team did not develop the application in their own. So what they do, they work with developers to resolve it. Now container technology comes in the picture, where a developer will write a Docker file, and that Docker file will be having all the steps to configure the application in the system. So now what they do, they hands over this set of information to the operation team, and because this image can run now on any container and platform, and it is guaranteed to run some same way everywhere. So ops team can use this image, how to deploy, and they are good to go. So I hope I was able to clear the Kubernetes basic concepts about containers. So in the next video, we will discuss about the orchestration. So please do like, share and subscribe and comment, and please connect with me if you face any issues. That's all. Thank you.